Hello, everyone. Thanks for joining us today for our next interview in the Women in STEM speaker series. Every Wednesday from now through September 30th, we'll introduce you to some inspiring female role models who are doing incredible work in a variety of STEM fields. This series is supported by the Association of Science and Technology Centers and IFTHEN through a gender equity grant, which supports projects aimed at increasing the representation of women and gender minorities in STEM. My name is Caitlin Zurcher. I'm the Senior Manager of Marketing, Public Relations, and Social Media at Carnegie Science Center. I first want to thank Michelle for being our sign language interpreter today. And today I'm very excited to talk to Dr. Rika Wright Carlsen, an Associate Professor of Mechanical and Biomedical Engineering at Robert Morris University. Rika, thanks so much for joining us today.
Yeah, thanks so much for having me. It's a pleasure and honor to be part of the speaker series.
Awesome. We're so excited to have you. I have a few questions prepared to get our conversation started, but folks that are watching live are encouraged to ask questions of their own. Just leave a comment with your question and we'll try to answer it later on. So Rika, to get us started, I wanted to ask if you could introduce yourself just to give us a quick overview of your job.
Yeah, absolutely. So right now I'm an associate professor of mechanical and biomedical engineering at Robert Morris University. So I teach both mechanical and biomedical engineering courses from the sophomore level up to the senior level. But let me give you a little bit of background of as far as my educational background goes. And I can tell you a little bit more about what actually got me interested in engineering, since that's the area that I'm really passionate about. So as far as my educational background, I got my bachelor's degree. I majored in mechanical engineering, but I also did a minor in bioengineering. So you can see how the mechanical and biomedical engineering comes together, right? And so after that, I went off to grad school, got my master's and PhD at Johns Hopkins University. And there I started studying traumatic brain injury. So I'll talk a lot more about that in a little bit. And then from there, I went to Carnegie Mellon University and did a few years of research in a nanorobotics laboratory. And so I worked with little micro robotic systems, which was really cool. So yeah, that's pretty much, my educational background. But I think, when students go off to college, right, one of the things they ask themselves is what do they want to major in? And so for me, engineering was something that I was inspired by, but it wasn't something that I considered right from the very beginning. So when I was younger, if you asked me what I wanted to do in the future, I actually wasn't quite sure. And I really struggled with figuring out what to do, as a major in college. And so I definitely had an interest in science and math. And so when I went off to college that very first year, I was undecided on a major. And so what I did was I reached out to classmates, talked to classmates who were in different majors, went to the career center, got information about different career opportunities. And then in the end, I decided on engineering, right? And the reason for engineering was because it sounded really interesting to me. There's definitely a lot that you can do as an engineer. And also it's a good major where you can get a good job just after 4 years. That was also very appealing to me as well. So one of the things that you find as an engineer is that you're out there to solve problems, right? And so you're taking that knowledge of science and mathematics and you're applying that to create and design new things. And so it was really a perfect blend of many of the things that I enjoyed. So it included science, included math, but it also included a lot of creativity. And so I really enjoyed creating and building things when I was younger. And now I get to continue to do that today in my job. And so through my research and then also working with students as well, with class projects and with prototyping and making new things. And so that's kind of what I do on a daily basis, but I can definitely get more into, some of the projects that we're working on as well.
Yeah, absolutely. I think that's really important for a lot of young people who are just starting out college. If you don't have your major picked out, that's where you're going to figure it out, is college, where you're taking different classes and exploring different opportunities. Was there any moment or certain class that made you decide, okay, I'm going to go with engineering?
I can't really think of a single moment or a single class, but I think once I started getting into the major, right? So I started taking a couple courses that second semester just to get a feel for it before I actually, switched into engineering. And in those courses, I started learning how to computer code, right, and do some programming. And so I found that to be really interesting. And then as I got further along in my undergraduate education, I got an opportunity to do research. So one of my professors reached out to me and asked if I wanted to do some research in the lab. And it wasn't something I even considered, right? But I took the opportunity and started to work in the lab. So we worked on piezoelectric actuators. So piezoelectric materials are really cool materials that convert energy from mechanical energy to electrical energy and vice versa. And so I got to work on these systems and then present at a conference, and that really reinforced my interest in research. And then there's a lot of other things too with like internships. So I actually did an internship abroad in another country. So I worked at a steel company in Japan for 6 months. And so having that opportunity, experiencing that, that really was like, wow, this is pretty cool, working at a research development lab. Being from Pittsburgh, the steel city, and then working in a steel company in Japan. I mean, that was just an amazing experience. And so all those things really reinforced, this is exactly what I want to do in the future. But I wouldn't have known that if I hadn't gone out and tried different things, right? So I think that is very important, like you said.
Yeah, I think that's an important message, and that's so cool that you got to intern in Japan. I think that's something maybe a lot of people don't recognize is, your internship can take you to different countries, and even your work can take you, all over the world.
Absolutely.
Yeah. So since you balance being a professor with conducting your own research, I'm curious to know what a typical day at work looks like for you.
Right. So there's definitely a lot that goes on. So a couple of different responsibilities. One obviously is teaching, right? So I teach a number of courses, again, from sophomore level up to the senior level. But in addition to that, there's a lot of work that goes on behind the scenes to prepare for those courses, to come up with activities and projects for the students. I also academically advise students. And so I work with students to help them explore particular options for the future and identify internship opportunities, help them figure out what classes they want to take. In addition to that, service is another important thing with being a professor. So I serve on a number of committees. I'm involved with outreach as well, doing events like this, and then also putting together my own programs to do some outreach to young girls, for example. And then in addition to that, I do the research side of things, right? So with research, I have a number of students who work in the lab. Undergraduate students are really excited about getting involved, right? So I usually have around 10 undergrad students in the lab at a given time. I'm working on different projects. I'm meeting with them a lot, trying to figure out the next steps in those projects. And then of course, with my own research, I do, a lot of coding and software, working with different types of software. So I can talk more about that in a minute here.
Yeah, if you want to just explain that now.
Yeah, absolutely. So my research is focused on traumatic brain injury. And so what we're trying to do is figure out ways to mitigate and prevent traumatic brain injury. And so one type of traumatic brain injury that you might be familiar with is a concussion, right? And that's something that we really want to try to limit, right? Especially with sports. And so if you think about traumatic brain injury, when you have an impact to the head, you really can't see what's happening inside the brain, right? So you don't really know how that injury progresses. So the role that I have is to create computational models that allow us to visualize what's actually happening inside the brain. And so we can understand exactly what the progression of injury is, and then we can figure out ways to mitigate or prevent injury in the future. So I can talk a little bit more about some of the things that we've learned from the research. And so I probably saw this helmet here, right, on this 3D printed head. Okay, so this 3D printed head is something that we printed in the lab and something that we use as far as doing some experiments with. But if you think about a helmet, right? So helmets are very important and they do a very good job at protecting your brain from skull fracture. All right, but it doesn't do as good of a job as protecting you from a concussion. And why is that, right? So when you have an impact to the head, okay, that causes motion of the head. All right, so there's two different kinds of motion, right? You have linear motion or linear acceleration, so where the head's moving in a single direction. So it's a lot like when you're riding in a car, right? And the car's accelerating. That's a linear acceleration. But then you also have rotational acceleration as well. Okay, and so, if you think about the helmet protecting your skull, right? It has a hard outer shell, it has a soft inner shell that kind of absorbs, or some soft padding, right? That absorbs that impact. But it doesn't prevent that type of motion. All right, now they're trying to create new helmets that can do a better job at preventing the motion of the head. But what we find is that it's that rotational motion that's actually the most dangerous when we talk about injury to the brain. And the reason for that is if you think about the brain, it's another little 3D printed brain here, okay? That the brain's very complex, right? Even if you look at the structure of it, it has lots of folds and so forth. And so the brain is also very compliant and soft, okay? So when you have rotation of the brain, what actually happens is your brain tissue deforms within the skull. And if that deformation becomes too large, that can actually cause damage to the cells within your brain. And so I can show you another really cool image here. So we do some imaging of the brain. So I don't know if you guys can see that, but this is called diffusion tensor imaging. So this actually maps out all the different neural connections within the brain. And so the different colors here represent different directions of those neural connections or the axons in the brain. And so if you think about it, you know, all that information gets transmitted from one region to the next along these neural tracks. And so what happens in brain injury is that when you have that deformation of the brain tissue, these tracks can become stretched. And if they get stretched beyond a particular threshold, or if it's too fast, that can cause injury to those particular cells. So with very severe traumatic brain injury, you might actually see in this type of imaging a loss of some of these neural tracks. Typically in a case of concussion, that doesn't occur because it's minimal injury, but you know, you also have to be very careful to, you know, not allow that to build up over time. And so what we do in our computational models is we take this imaging data, incorporate that into our models so that we can see what parts of the brain are more vulnerable to injury. So if you want to see, you know, what those computational simulations look like, let me go ahead and play that here. So this is what a computational simulation might look like. So here we take a slice of the brain. So this is a sagittal slice, so cut right down the middle. And I don't know if you can see that, but there's different colors, right? And so those colors represent areas of the brain that have more deformation or more strain. And so those are the regions that might be more vulnerable to injury. And so it really depends on a lot of different factors, depending on how the head rotates, you know, which way the forces are coming from. But those are all things that we're studying in order to make, you know, things safer as far as designing better helmets or coming up with new prevention protocols to prevent this type of injury.
Wow, that's amazing. That's awesome. I know when we mentioned your title, Associate Professor of Mechanical and Biomedical Engineering, I'm sure a lot of us aren't really too familiar with the different types of engineering. So if you could give just a quick like textbook type definition of mechanical and biomedical engineering and how they come together in your work.
Absolutely. Yeah, there's definitely a ton of different kinds of engineering majors. And so, yeah, so mechanical and biomedical engineering are the two that I've focused on and studied. So mechanical engineering is actually one of the broadest engineering disciplines. And so it's mainly focused on looking at the design of machines and processes, right? And so we really look at, in my work, looking at the effect of forces on different objects. Okay, so if you think about traumatic brain injury, right, you have a force to the head, and then you look at how the brain and the skull might respond to that. And so that's part of the mechanical engineering. Now, biomedical engineering, you're taking those engineering principles and applying it to medicine. And so it's actually very broad, right? So you can think of like software and biomedical engineering combined where you're developing like medical imaging systems, right? Or you can think of, in my case, biomedical engineering mechanics combined where we look at biomechanics, so the effect of forces on the body and how that might lead to injury. But biomedical engineering can also involve like tissue engineering, for example. So it's a very broad field. So in general, yeah, biomedical engineering, you take engineering concepts, apply that to medicine, and then mechanical engineering is just a lot broader and encompasses a lot of different fields.
Awesome. Thanks for explaining that.
Yeah.
And I was also curious, you know, as a professor, do you ever notice certain traits or skills that your students have that really make you think that person's going to make a great engineer someday?
Yeah, absolutely. So I think just having, you know, that creative mindset, right, and wanting to discover new things, I think is really important. Students who are really passionate about just, you know, learning about new things and seeing how things work. And I have students who really love to build and design things. So maybe in the classroom, they might not do as well on exams, but once they go out and work on projects, they're absolutely brilliant as far as some of the things that they design, right? So they really enjoy, you know, working with computational software and creating 3D models, prototyping. And so those are all things that make you a great engineer in the future as well.
Awesome. And then kind of in that same vein, would you have any advice for young girls or women who are just starting out their studies who are interested in your field or STEM fields in general?
Right. So the biggest advice I can give you is just go out and try new things and get some experience, right? So there's a lot of great STEM programs that are out there. I know the Carnegie Science Center has some great programs. I also offer a summer camp over the summertime where students can get some experience with biomedical engineering. So we do a lot of hands-on activities in the lab. We talk about, for example, wearable sensors. So there's another little sensor here that can measure acceleration of the head. And so, you know, we talk about that. We learn how to do 3D printing, how to create models from medical imaging data. And so just getting that experience, you get to learn and figure out what it is that you really like and what you don't like. And from that information, you can figure out what you want to do in the future. And so also it can be helpful just to talk to people who are in different fields like mine, for example. I think everybody's experience is very different. So even if you talk to two people who are mechanical engineers, you know, what they do might be very different. And, you know, their job, what it entails might be very different as well. I mean, as far as engineering goes, right, you can have a lot of different professions within engineering. You could be a sales engineer, you could be a test engineer, you could be a design engineer. And so not all engineers do the exact same thing when they start working. So yeah, definitely go out, talk to people would be the greatest advice that I have. And then, yeah. And then also I think, you know, STEM education provides a good foundation, right? No matter what career path you go down. So whether it's, you know, you end up going to business or law or education or medicine, right? The skills that you learn as an engineer or in any of the STEM fields is critical thinking skills, the analytical skills, they can all be really helpful down the road.
Yeah, I know something we talk a lot about at the Science Center is how STEM is so much more than science, technology, engineering, and math.
Right.
It's those creative, collaborative skills and design thinking and analytics. There's so much that goes into it that really can apply to really any career path that you can think of.
Yeah, absolutely.
Yeah. Has there been anyone that's really inspired you or mentored you as you were, you know, working on your studies or just starting out in your career?
Yeah, definitely. So I definitely had a lot of role models and people who inspired me and really were instrumental for me, you know, going through the whole educational pathway. So as an undergrad, if I think back, you know, with my engineering professors, I only had, I think, one female engineering professor. So she was definitely a role model for me, especially now that I'm in that profession. But also when I started doing research, there's another research professor who was absolutely brilliant. And she was also very creative as well. And she had a really like true passion for research. And so it's just awesome working with her. She taught me a lot of different technical skills. And so with her, we worked on micro electromechanical systems. So there's these little tiny, you know, systems that are built on a chip. And so I thought that was just amazing. And then we would just go in the lab to try new things, right? She'd come up with an idea and would be like, I wonder if this will work. And we go in the lab and try it out, you know, and I thought that was just awesome to be able to create new things and just try things on the whim like that. And then also she taught me the importance of the scientific literature, right? So up until that point, I only read my textbooks, right, were my main source of information and where I got most of my knowledge from, right? So in class, you study your textbooks, for example. But I didn't realize that there was a broad range of information and knowledge that you can gain from scientific journal papers. And so a lot of the cutting edge research is published in these papers. And up until that point, I didn't realize that. So, you know, being able to talk to her and then starting to read these papers and realizing how much you can learn from them, that was really great for me to get that experience. And that's something I do even to this day, right? Reading a lot of scientific papers.
Yeah, that's awesome. And kind of like you said earlier too, like it's so important just to make those connections and talk to people who are in the career that you're looking at, to just, you know, that there's no better way to get a sense of what that job is going to look like than by listening to their stories.
Right, absolutely.
Yeah. And then with this speaker series, you know, we're really emphasizing the importance of showcasing women in STEM. So I wanted to ask, how important is representation in science and technology and engineering fields?
Yeah, so I think it's extremely important. And I'll take an example here more from the engineering standpoint. So if you think about engineering design, for example, right? So with the engineering design process, you identify a problem, you try to understand the constraints, specifications, but then the next step is to brainstorm ideas, right? And oftentimes as you go through that brainstorming process and go through ideation, you're drawing examples from your own life experiences, right? So a lot of your designs come from things that you've experienced in the past. And that's where representation becomes really important, because if you have a diversity of perspectives and thoughts and beliefs, right? Then when you go through that engineering design process, start to brainstorm ideas, you have a wide range of designs that you're starting to explore, right? Otherwise, if you have a lack of diversity, you know, the design space is very constrained and you might have a very homogeneous view of humanity. And so, you know, if you have people bringing in different perspectives, you start to consider everything in that design process. And so that final solution that you have won't be blind to the needs of certain individuals, but it will include everybody, right? So really designing for people, right? And so a lot with, you know, biomedical engineering design is with human-centered design. So we're coming up with solutions to help people. And so having those additional perspectives is really important in that process.
Awesome. Well, I love that answer. I'm going to go through some of the questions that we've received on Facebook and see if some things that our viewers are curious about. Someone asked, what experiences or classes would you suggest to someone who is interested in engineering?
Okay, so if you're in high school, I think there's courses, right, that kind of explore different engineering disciplines, and just taking the various science classes as well. So, I mean, there's a wide variety of things that you can do as an engineer. And so just exploring, you know, different subject matters and trying to figure out which ones you really enjoy and you really like. I think another important course that applies in a lot of engineering fields is computer programming, right? So these days, you know, a lot of devices that you create also have, you know, computational elements, electronics that's involved with it. So having some programming background can be really helpful in your career. So for example, I absolutely love programming. It's something that I enjoy just because you can, anything that you think about, you can actually create with a program. You can get it to do what you want. It is challenging though, and you know, it's something that you just have to stick with, because with programming, the first time you write a code, it usually doesn't work, right? So you have to keep at it. But that can also be a great course to take in the future.
Yeah. Another question, you know, because you've mentioned like as you're a professor and you also do your own research, so a busy career, but how do you manage work-life balance?
That's a really good question, right? So it's definitely very busy, and in a given day, you know, you have so much that you want to do, and you can never fit everything in with the number of hours that there are in a given day. So I think it's all about prioritizing, right? So figuring out what's important to you and then focusing on that throughout the day. So when I'm at work, you know, just focusing on what I'm doing at that particular moment, you know, when I'm talking to a student versus, you know, working on research. And then when I'm at home too, you know, if you're with family, you know, focusing on giving your time to your family. And so really, I mean, it's difficult, right? But if you can prioritize, that really helps you as far as trying to maintain that work-life balance. And then it's also helpful too to have a lot of activities outside of work as well that you enjoy and can relieve some stress as well. So, you know, things like being outdoors, if you enjoy that. I enjoy snowboarding during the winter time. In the past, I did a lot of martial arts. That was a great stress reliever as well.
Awesome. Yeah, it's definitely a work-life balance, and you know, it takes practice, but it is so important to really your whole life. One other question. What would you say is your biggest accomplishment so far in your career?
That's a good question. I mean, for me, you know, going through the whole educational process, I was the first in my family to get a 4-year degree, and then going off and getting my PhD was a huge accomplishment for me. And then also, you know, every day with the research, I mean, there are many accomplishments, but every time we make progress, I really enjoy that. And for me, also working on multidisciplinary teams. So I work with people in a lot of different fields. So for example, the TBI, traumatic brain injury research, I work with clinicians who work with patients. I work with helmet manufacturers, work with people who are in biology and biochemistry. And so as we all work together to solve a common problem, and we're all passionate about that, right? Each time we make some breakthrough in the research, that's also accomplishments that I can be really proud of, and that can also help other people in the future.
That's awesome. It looks like those are all the questions that we have for now. Do you have any final words of wisdom or advice to the people watching today?
Yeah, absolutely. So if you're interested in the STEM fields, greatest advice is just to go out and pursue it. Definitely believe in yourself and have confidence in your own abilities. I know that's always my biggest obstacle is myself, right? When I go out and try new things. So, as you challenge yourself, there will be times where you might not succeed or meet your goals, but you just have to keep trying and keep, going after it. So through a lot of hard work, you can definitely achieve what you want to achieve in the future. And yeah, I wish you guys all the best.
Awesome. That is excellent advice. Thank you again so much for joining us today, for sharing your story and just telling us all about the awesome research that you're doing and how you're making a difference in the world. We really appreciate the time that you've taken today.
All right. Yeah, thanks so much.
Great. And we hope that everyone watching will join us next week for a conversation with Ellen Bachman, an inside sales engineer at Eaton. We'll talk to her next Wednesday, August 19th at 11 a.m. right here on Facebook Live. More details and our full list of upcoming speakers for this series are on our website, carnegiesciencecenter.org. Thanks so much for watching.